Been recording during the whole break. Okay.
Yeah.
All right.
All right. Well, you'll have to.
Well, you could.
So, okay. So, how many people want to stop with this? Not put RC circuits on the test. It means we will finish RC circuits the week after the midterm, before we start magnetism. So, you know, it fits better with what we're doing now because this doesn't have anything to do with magnetism. But I think for the sake of the fact that we just did a whole bunch of stuff, and I'm getting so many blank stares, I just want to limit that.
I'm ambivalent, yeah. Whether we have it on.
I mean, people who've had circuits, you know how to do it either way.
Yeah.
You've seen it before. But people who haven't, I think your vote's going to play a bigger role. So, and just for time, I mean, it's 2:40.
Yeah.
It's been a long day. Okay, so we'll do that. The last section in the lecture after RC circuits is household circuits, so that will also be something we'll cover after the week after the midterm. So shifting gears, review. Okay, midterm review. So let's cover the basics of what you can expect from a midterm. So those of you who've had me before, you know about my exams. You can have one sheet of notes, 8.5 by 11, double-sided. I don't care what you put on it. I don't even look at it. It's really something I hope you've been working on throughout the term and been using as a study aid. And already posted on the course website under the midterm exam folder is an equation sheet that comes with the exam. You don't need to print that. I'm just showing you that comes with the exam with a whole bunch of equations already on it. So you don't necessarily need to fill up your one sheet of notes with equations. If you want to put example problems or a table with definitions and variables and units and stuff like that, whatever it is that you find yourself struggling with, you know, that's what you can put on your sheet.
Will the table have constants on it? Or like
Oh yes, yeah. The equation sheet that comes with your exam has any constants you could need. Mm-hmm.
like 8 points.
And let's see what else. You'll have 2 hours for the exam. It's going to go 9:30 to 11:30 next Friday morning. Obviously, it's closed book besides your sheet of notes. Any other questions about how the exam operates? Not quite like what is on the exam, but.
How many questions are there?
5 questions. The 4 of them will be like standard workout style homework problems that you know and love. And 1 will have a series of multiple choice questions, like the review questions we've done at the beginning of class. And I just, draw from ones you've already seen before.
Like the bunch of multi-choice, like clicker questions.
All the clicker questions, yeah.
Just sort of like the last one, right?
Yeah, exactly. I mean, here's some, these type of clicker questions. They're a good thing to know. So in this week's lecture folder, there's 3 weekly online activities. So again, those aren't things you have to do. Those are for when I have a night class. They're required to do those. But the first 2, week 5 and 6, have, they're actually like good learning tools. So if you want to do those for studying, that would probably be really beneficial. I'm not sure of both of them, but I know one of them has multiple choice questions on there as well. The solutions should already be posted, so you can study those solutions. But yeah.
Is that for like, also that's applicable, did we have an online for the first week? We didn't, did we?
We did it in class.
Okay, so is that questions from that going to be?
Sure. Any multiple choice questions, whether it's been in the lecture or the weekly online activities that we've done, are fair game, worth studying. So yeah, that's basically what you can expect from the test. About 10 multiple choice questions and 4 workout style problems. And just like the things I mark you off on your homework for, that's how I grade the tests. So you got to start with the starting equation without numbers, show your work, show your answer, show units, standard stuff.
Can you give us some sort of symposium before I attend?
Yeah, let's talk through each lecture, and we can discuss specific topics that are definitely worth studying, and then if there happens to be any things that I don't think I would put on the exam, then we can talk about those. So week 1 was gravitation. I'm pretty positive I wouldn't put a black hole problem on the test because there's really not a whole lot of work to be done. Like, we only ever solved for 2 things. So those aren't very interesting problems. So they probably wouldn't show up on the test. So I will go through, I'm just looking through the examples we did in class and the homework problems, and if there's any problem that I say definitely wouldn't be anything like this on the test, then I will let you know.
Pretty sure I can get close to the pages without saying anything.
Yeah, I know.
Well, I mean, you know, like I said, probably won't see black holes on the test because there's not a whole lot of stuff to study. So, like problem 13.36, I'm going to put this on the board. You can skip studying black holes. And, you know, Stephen Hawking might say that's a good idea anyway, since we don't really understand what's happening with black holes. Everything we know about them might be wrong. Okay. So any problem relating to black holes, you can go ahead and skip. We didn't have that many, that's true. Okay, so any questions about lecture 1?
Is there any that would be more, no, any or all are subject to your picking? Okay, fine.
Lecture 2. I will say, since this course is electricity and magnetism, there's going to be a less emphasis on gravitation because that's not the core focus of this course. So if you're going to spend most of your time studying, I would study the last 4 lectures and spend less time working on the first lecture. Okay, yeah, okay. So electric charge and electric field. And then if you guys had any questions about anything from these sections while we're going through, now is a good time to bring them up. Really common questions that show up from this section are like the 1 and 2-dimensional static charges. You've like got, you know, they tell you on the coordinate axis like which charges are located where, and it says find the electric field at this point, or find the forces on this charge due to the other charges. So example 21.4, example 21.1, example 21.3,
You're putting it on the board.
example 21.8. So those are all like static charges, and you're looking for electric force or electric field. Those are ones I've put on exams very frequently. Okay, so good study ones. You're not going to have to do any integral stuff. So example 2110 had us deriving an expression for the electric field due to line of charge. You don't have to derive stuff we've already derived in class. So you wouldn't have to do that one on the test. Example 2110. Let's see. 2133 is a cool problem. So another good one is this problem 2130, where you've got a point in the middle of 4 charges that make a square, and you have to find the electric field in the middle. 2137's that one's a weird one, but that's probably overly complicated for the test. 2176 is a good one to study. You've got 2 charges and then a third charge, and wants to know what would the acceleration on that charge be. So it's relating electric force to mass times acceleration. Yeah, so there's those are probably the ones you can expect. The ones relating to just using the equations we derived for electric field on surfaces that have surface charge density, those probably are less likely to come up. Like book problem 2110, we just had to apply the formula we had for electric charge near a sheet. So that's probably less likely to come up. Okay, lecture 3. All right, Gauss's law. So the things that we kept hammering on with Gauss's law was a lot of those problems where we could logically figure things out. We said we don't care about things outside this Gaussian surface because Gauss's law only worries about stuff inside. Or we can treat everything inside this Gaussian surface as a point charge because it's spherically symmetrical. So those are the those key theorems that we used in Gauss's law that simplified things down. Those are probably good ones to study. Again, there was a lot of problems we did where we had to do these integrals, where we said find the electric field for every point inside and outside of this wire. Not going to have to integrate on the test. So that would be examples 22.5, 22.9.
These are ones we do or don't have to.
You wouldn't have to do something like that on the test. And so a lot of the things we did in class, we were just deriving expressions that we could use later. Like we derived an expression for the electric field due to a line of charge. We then used that equation later on. So we wouldn't have to rederive things we've already derived. So problems that are probably good to study, problem 22.8, that's the one I graded on your homework. So problem 22.1, I'm not sure, or 22.21. I just have the book solution, and of course the book doesn't show me all the work, but was that one you could use a lot of logic to answer, or one that required a lot of integration?
2221.
2221. Homework, yeah.
I don't remember if I like that. This is 22. There was a lot of nagging.
Yeah, I don't see a lot of just logic.
No.
Okay, well.
It's plugging numbers in.
Okay.
You know, I mean, part of it was the other stuff, there was both, because you had to decide what was outside the sphere.
Yeah, yeah. Okay.
So,
Well, I don't, okay.
that was
Well,
21, 21, right, so not that one then.
and 2239 is way too hard for a test. So that's another one where you have to integrate.
No,
I don't know. I guess,
question,
I don't think so.
okay.
I don't think so. I'll put, no. Definitely study the multiple choice questions we did for Gauss's law, and again, just like the logical concepts that we covered. I don't know that there's a whole lot of like test questions that wouldn't ruin your day.
Well,
Well, like the other one I graded was problem 2252. That one wasn't so bad because you just could use some logic to simplify things down to, like, you say everything outside the sphere I can ignore it, or everything inside acts like a point charge, so I can just use my point charge equation. So that's a good Gauss's law problem to study. Okay, and lecture 4. This was electric potential and capacitance. A lot of stuff with energy, like potential and kinetic energy and work. I don't think that that's going to come up on the test. We didn't really use that functionally. I like more applied problems, so pretty much once we actually got to capacitors, we actually started using potential after we developed it. That's the stuff that's going to be more relevant, chapter 24 stuff. Obviously, you might see a bunch of capacitors and you have to find the equivalent capacitance and show all your steps. That's been something that's come up on a test before. Just like with resistors, you might see one where you've got to reduce all the resistors down. So dielectrics, you might see a problem where you've got to solve a bunch of stuff for the capacitor and then say, okay, now we put a dielectric in it. How does everything change? So that's definitely more likely to see on this test. So, yeah, I'm looking at all these examples we did in chapter 23, and I would say probably nothing from chapter 20. None of those examples from chapter 23 anyway. Let me see about book problems. Nope. Nope. No. 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 Yeah, okay. Okay, yeah.
so wait, didn't we just turn in homework from last week?
You turned in that lecture, homework 4?
Yes.
Yeah, today.
So we wouldn't be getting it back this day?
No, but the solutions are up there, so you can
Okay,
study the
okay.
solutions.
Got it, okay.
Yeah. Okay, so chapter 24, again, like the reducing the capacitors down to one equivalent capacitance. Example 24.7, that was where we charged up a capacitor, connected it to another capacitor, and saw how the charges shared between the two, and we talked about internal energy and how that changed. That is a really good one to study. So example 24.7, and they, let's see, they kind of continue that one later on? No. Okay, so yeah, 24.7, no spherical or cylindrical capacitors. And then that one we did with like the before and after with the dielectric, 2410.
The example?
Example 2410. That had like everything you could possibly solve for. And then 2411 is the same problem with just more things to solve for. 2410 and 2411.
So no or yes?
Yes. Okay, let's see, from your homework. Yeah, you saw my reaction to every problem from chapter 23.
That's how I felt too.
Yeah, we were so thrilled.
Yeah, I will keep that in mind for future
Future students that will
future students that are suffering. All the chapter 24 problems look reasonable. Is that how you guys felt? Yeah, okay. Yeah. Okay, and then from today, obviously nothing about RC circuits or household circuits, because we didn't get that far. Okay. Definitely spend some time practicing these multi-loop resistor problems.
You mean the RF?
The mesh analysis, yeah, the RF thing. I always put one of those either on the midterm or on the final. So if you don't see it on the midterm, it will be on the final. That's a guarantee. Yeah, so.
What if we see it on the midterm, it won't be on the final?
That's right. I promise you. I guarantee it. I don't repeat topics on the final. So if it's on the midterm, it won't be on the final. Otherwise, I mean, like everything else we did was just really building up to looking at multiple resistors. I mean, make sure that you can solve for other things besides current. So the problem we did the hard part of finding solving the mesh analysis, and everyone practiced on their calculators just to get the currents. There was a part B for that problem, and that was finding a voltage drop between 2 points listed. So that's something to make sure you can do. There's problems we did applying power, the power equation, so practice those problems. That brings me up to the point that there's probably going to be things on your homework that you don't need to study. So the homework solutions for this week have already been posted. So that way you can study the correct ways to do everything while you're studying for the test. But if you want 10 points on your homework, you actually have to turn it in next week. All right? So it's for completion. You actually have to do it, and I need to see it, but I'm not grading it. Make sense? Yeah. So any problems relating to RC circuits or household circuits you don't have to do, so I should probably write that over here. Yeah.
So which ones do you know?
I'm going to write them down right now. Okay. Okay, where does he start? All right, so we got through all of chapter 25. So the first one is 2650, 2653, 2665, so that's a multi-loop resistor problem. The book doesn't talk about mesh analysis at all. So if you want to know mesh analysis, you'll have to look at the solution. I have my written solution that does mesh analysis for that one. So the book solution's there as well, you just won't find it very useful.
So do you want us to do 2665 then?
Yes, yes, yes.
Oh, so the ones we can skip are just those two.
So far, and 2674. Okay. All right, that's all right, because there was 11 homework problems, and that's brutal. So now it's down to a more manageable number.
9. No.
8.
8. I just wrote that.
All right, any questions about anything that we've covered, whether you're going to see it, whether you...
I guess, I haven't taken any of your tests before, so like, when you said the 5 problems, are there like, A through F for each problem, or?
No, not an A through F, like,
Yeah,
like
wow.
A, B, maybe C.
The way she stops
Yeah.
at F, it's.
I go all the way to Z.
Most I ever went then she starts using Roman numerals and Greek characters.
Runs out of those, starts adding crime.
No, my problems are not like some of the book problems. I guess, yeah, let me see. If you are, well, this is what I've observed. I get some people that give up after an hour and just leave, and they did not do well. And then I get like rock stars who finish in an hour and a half. And most people do not finish the exam. So they're still working after 2 hours, and then, yeah.
With that in mind, do we get more points for setting up problems or for?
Yeah, you get,
writing
yeah,
something.
yes, Shelley, spot on. If you don't know what to do, don't leave it blank.
Yeah, yeah.
Put every equation you think is relevant, right?
Yeah.
Put something down. Even if you don't know an answer, but you know the answer's units, blank newtons, whatever, you'll get units points.
So do that for all the questions and then go back and go over.
What's that?
So do that for all the questions and then go back and do the work.
If you want. I mean,
It's good
I
to
think,
look through the
like, you can get as far as you think you're going to go. You're like, shh, I got 5 minutes left. And then you just go like, oh, ... blank, units. At least you get unit points. Yeah, it makes me cry a little inside when people leave a problem blank. Because I'm like, you just get like, yeah, I mean, write down the givens. You get points just sometimes for just writing down what they give you and doing the conversions.
Oh, you didn't know that? Oh, yeah.
Yeah.
Trust me.
If I wrote like a paragraph about how I would approach the problem, but I don't know, and identify like, but I don't know this or this, but this is what I do know, like.
Yeah, I mean, it's if it makes sense and I can identify like logical steps. Yeah, you know, I can give you partial credit.
Gave me credit, and a professor gave me 0 points, so good to know.
Yeah, I mean, if it's gobbledygook, then I can't help you. But if I see logical like